Hello, in this quick video I'm going to be talking about Bayes' theorem. This is how Bayes' theorem is presented in the textbooks. Obviously at first glance this just looks like a big kind of algebraic mess. I'm going to try and help you make sense of what it means. Just a quick note on notation. This vertical line here means given, so this first bit here means the probability of A given B, which is what Bayes' theorem is. It's about conditional probability. What is the probability of an event occurring given that we know another event has already occurred? Right, so if we look at this space here represents all possible outcomes. This circle represents the possibility of event B, this circle represents a possibility of event A, and this intersection between them in the middle is the probability of A and B both occurring. So hopefully that's straightforward enough. So what we want to get is how do we get to this middle bit? How do we get to the probability of both A and B occurring? And that, by the way, in the textbooks is denoted like this. That little symbol that kind of looks like a lowercase n, that means intersection. So when you see that in the textbooks, that means the probability of the intersection of A and B, i.e. that green bit, means the probability of A and B occurring. What is it? Well, obviously for A and B to both occur, we need A to occur. So let's start with that, probability of A. And then building on that, we also need the probability of B given that A has occurred. Probability of B given that A has occurred, right? To get to this middle bit, you need A to occur, and then given that A has occurred, you need B to occur. So it's probability of A times probability of B given that A has occurred. As you might have guessed, this works exactly the same the other way around. You can write, you can get to this intersection by saying it's the probability of B, so this bit here, and once we're inside this circle, is the probability of A given that B has already occurred. Probability of A given B. So these are all the same. I'm going to take these last two bits and just write them out on the same line here, like this. You've got the probability of A times probability of B given A is the same the other way round. It's the same as the probability of B times the probability of A given B, and these are both equal to this term up here, which is the notation for this green bit in the middle, the intersection. So that's the probability of A and B occurring. Now, we've actually already derived Bayes' theorem. That is it. All we need to do now is manipulate the algebra slightly, and you will get to this as you see in the textbooks. So what do we need? We need to solve for probability of A and B. How do we solve for that? We just divide across by B, probability of B I should say. So probability of A given B equals, I'm just going to write the conditional probability first, because that's how it's written normally in the textbooks, but obviously it doesn't really matter which way around. So probability of B given A times probability of A. That's just that, just the other way around. And then obviously we've divided across by the probability of B. And just with that small manipulation of the algebra, we've got to our original algebraic mess, as I called it here. So it's actually really simple. Once you've intuitively derived this bit here, the intersection of the probability of A and B, you just manipulate the algebra a little bit, divide across by the probability of B, and that is Bayes' theorem as you see it in the textbooks. I hope that helped slightly.